So this is a the most basic of components, a button with an outline and a hover effect. And I will use component in this talk very liberally. It doesn't matter if you use a framework, if you use web components with Shadow DOM, or if you just reuse HTML styled with CSS. As long as it's a reusable blob of HTML, CSS, and sometimes JavaScript, it's a component conceptually. And the simplest of components is a button. So here we have two variations, and we've actually hard-coded these variations by having separate classes. There's a lot of repetition. And as you know, we can fix this repetition by introducing a color variable and setting it to black as a default, and then using that color variable everywhere where we define a color. And that allows us to simplify down our variation from 2 rules and 5 and 4 declarations to just 1 rule and a single color declaration. And furthermore, this allows us to create dynamic variations, even in the inline style, which just work just fine. And we could even write JavaScript to set the variation. We could have JavaScript that creates a dynamic variation every time we click the button. So here I'm writing some JavaScript that will set the accent color of this button to a random hue every time I click it. So every time I'm clicking it, I get a new color. So the first lesson is that CSS variables are just regular properties. In fact, they're inherited properties. Now, one thing is, we've set our fallback. We need a value for when the color property is not set. And right now, we've set it on the button itself. This has several problems. It breaks inheritance. It means we cannot just set this variable on the root and have it trickle down on every component on the page. And it also means that everyone using this component and overriding our CSS would need to use at least the same specificity that we've used, which is not great, because they shouldn't need to know what CSS we've written. So how can we fix that? We can use a fallback, as you know. At this point, I imagine most of you are on the same page. But the problem is now we've had to repeat this value 3 times. We've fixed the problem with the specificity and the lack of inheritance, but we had to repeat this value 3 times. And I know what you're going to say. You're going to say, well, yeah, variables help us reduce duplication, so we can just put this fallback in another variable and use that in the fallback. And yes, this does solve the immediate problem, but is this nice? This is awful. Every time we use this variable, we need to repeat this entire long thing. Imagine a whole design system structured this way. So no, there's a better way. We can define what I call pseudo-private variables. Prefix the same variable name with an underscore. It's just a convention. Underscores do not do anything special. And then everywhere where we want to use this variable with a fallback, we just use the one we've defined internally with the underscore. And it's just 1 extra character instead of, I don't know, 20. So yeah, the second lesson is that pseudo-private variables help us succinctly reduce fallback duplication. And also, it's kind of a nice self-documenting code. Like, you know, you see if you look at the implementation of the component, you kind of see all the variables in the beginning and their initial values right there. Now, what else can we do? Oops. Now, what else can we do? We want to have a transition effect so that when we hover over the button, we don't just get this abrupt, we don't just get an abrupt color, but we want to get a nice transition. But we don't actually like the default transition that we get with the default of the transition property. So we want to have the border like growing inwards. So instead, we want to use a box shadow that is styled as a background. And we can do that. And it works. It grows inwards. And what is the takeaway here? That whoever is using our code, whoever is using this button component, did not need to override anything. If they had created 5 different variations of our button, they did not need to go into their CSS and change how their hover effect works. Before CSS variables, everyone would need to be notified that we changed how the hover effect works so that they also change their code that specifies this hover effect. And essentially, this way, CSS variables allow us to create what I call a CSS API. And components are already taking advantage of it. Shoelace, my favorite component library, uses this exposes like a list of their variables and the values they take. Now let's go back to the previous state and get rid of the transition to see something else. So let's suppose that instead of these two variations, what we wanted to do was we wanted to have a rainbow button that actually goes through all the colors smoothly. And when we hover over it, it actually goes through the entire rainbow. Can we do that? Well, let's give it a shot. We define that our color variable is an HSL color where the hue is another variable. And then we define a keyframes rule that animates this color hue from 0 to 360, but for now, just because we're debugging, let's go from 0 to 180, like halfway through the hue circle. And let's specify an animation so that we can actually have this smoothly animate. And notice that we didn't get no smooth animation. There's nothing smooth about this. It just goes from a hue of 0 to a hue of 180, just abruptly like this. Where's the animation? So the problem here is that CSS variables cannot be interpolated unless we give them a type, unless we define them with that property. So we're going to define that our color hue variable is a number with an initial value of 0. All of these descriptors are mandatory, and it inherits. And notice that now we got our animation just fine. And now we can also change it from like 0 to 360 like we were planning to. So, and there's also a JavaScript API in case you need to register like a ton of them. And also we can define our actual color variable. We can also define that as a color value. We can give it a type. There's a bunch of different types that we can use. And then we don't actually need the pseudo-private variable anymore. We can just use dash color. However, this is not always a better solution than the pseudo-private variable, because for many reasons, at property is global. Unless you're actually defining a web component in an actual shadow root, at property is global, and you probably don't want to have a black initial value on every single color property, on every single dash color property on your page. Also, at property has much worse browser support than just using plain CSS variables, which pseudo-private variables are. I believe WebKit is already working on implementing it, and Firefox, I mean, who knows at this point. But the good and bad thing is that when Chrome implements something, it does get like 70+% market share. So it does look bad, but it's not actually as bad as it looks. And there are ways to detect it and have fallbacks. So now, Act 2, the glossy button. What is this going to teach us? So I've mentioned that component libraries these days use CSS properties as a sort of CSS API. And at the tag, we have guidelines for how web components should be created. And most of these are pretty much followed by popular libraries, but one of them, don't use custom attributes for styling, instead use custom properties or CSS shadow parts. This is not really followed out there. Even Shoelace, which is generally awesome, it doesn't really follow it fully. Some things are styled with CSS properties. Other things have attributes, like this. There's a size attribute. There's an outline attribute to create an outlined button. There is even a pill attribute to make the corners round like this. So these are very smart developers. Like, why are they using attributes for styling? One of the biggest anti-patterns of HTML. And the reason is because they can't do it any other way. We cannot have higher-level custom properties today, not properly at least. I'm going to show you some workarounds to do it, but not properly. We can't say, if the pill custom property is on, then apply this border radius. Otherwise, don't. Soon, we're going to have container queries that do this. Yuna showed you container queries about size, but also container queries about style are coming, where we will be able to have conditionals about specific values of a custom property. And I'm actually even more excited about these. But these are these would take even longer to arrive. There's currently an implementation in Chrome Canary, and that's about it. However, there are workarounds that I promised you. So here, what do we have here? We have two different styles for this button. We have a custom property that pulls in a bunch of different things: gradients, shadows, even a different line height. And notice this, I'm applying this glossy property on every other button, and it's making every other button glossy. And just so you believe me, I'm going to make every button glossy. And now I'm going to turn it off. And now it's off. And now it's on again. So how is this implemented? We're not going to see the whole implementation because time, but I'm going to show you the main thing, and that is called a space toggle. It's based on the idea that a space is a perfectly valid value for a custom property, and it just replaces the entire custom property call with nothing. So as long as what remains is valid, you have a perfectly valid value. So here, we don't get a gradient because glossy is set to white space. But what if we didn't have glossy? Then we get the gradient because the gradient is the fallback. And we can actually explicitly call for this if we use the keyword initial. And we can use this to pull in like different values on different unrelated properties. And we could even do math. Like here, we wanted to have 1.5 in one case and 1.1 when glossy was on. So now, when glossy is set to white space, then we get 1.5. If it's not present, or if it is present but it's set to initial, then we get the fallback and it's 1.1 because the math operation's happening. And that is basically the core. We just repeat this over and over, like transparencies of colors and box shadows and borders and all of that. And we get the glossy mix-in that I showed you earlier. There's even, like, you can do extreme things with space toggle. Like Jane Ori made an entire Minesweeper game using space toggle. And you might be thinking, dude, if I submit a pull request using this, I'm gonna get hit. Like, I'm gonna get cursed. However, you can actually use it in production with code that's shared by other people if you just alias these two values into nice readable names like on and off or true or false or whatever. Like, you can call them anything you want. And then nobody needs to know how space toggle works. You just tell them, use this value to turn it on and use this value to turn it off. And one sort of more tame case for space toggle is for progressive enhancement. And here's an example. So one feature that's coming, but it's not supported everywhere yet, is specifying the color space for gradient interpolation, which can make really much nicer gradients. Safari supports this right now. Chrome doesn't, but they're working on it. And Firefox later in the future. So what can we do in the meantime to get these nicer gradients in the browsers that do support them? Well, we can use @supports and specify every gradient twice. But that's not very nice, is it? What we can do instead is just in one place in our CSS, we define this --inlab custom property, and then we override it with the actual tokens of inlab comma when color space interpolation is supported. And then everywhere we define a gradient, we just refer to this token, and we get nicer gradients in Safari or whichever browser implements color space interpolation, and in other browsers, we just get the old sRGB interpolation. And now for Act 3, the bar chart. So the bar chart's my favorite because it will show so many different things. This is what we're going to make in the end. It's a bar chart where there's one variable controlling the height of the bars. It's also displayed on the actual bar. And there's even a color as an extra cue for the actual number that we have. So how can we implement this in CSS? There's no JavaScript here. So here's where we started from, and we used some Flexbox to style this as a bar chart. And now we've used percentages for now, and we've applied this to the height. And our first thought was, I'm going to use generated content to display this percentage on the bars. But nothing's happening. Why is nothing happening? I'm looking at my code, scratching my head and thinking, why is it not working? Wait a second, I cannot show percentages in the content property. Of course this is not going to work. So my second thought was, well, I'm going to change these percentages to be plain numbers. And to have a percentage for the height, I'm going to multiply it by 1%. But even though this works for the bar height, it still doesn't work for the content. But also, as a side point, it's actually a better practice to go from a number, to have custom properties that are plain numbers and convert them to numbers with units in your CSS. Because you can always go from a number to a unit. You can never go from a unit to a number. If you have a percentage, you cannot do math on that and get a number. If you have a px value, a length value, you cannot do math on that and go and get a plain number. In the future, we'll be able to. We'll be able to do the inverse of this multiplication, just divide. Right now, we cannot. So, in general, it's a good practice to use variables for pure data and not CSS values. So, now that we're using plain numbers, even though we cannot display them directly, but we can use what is called the counter trick. And brace yourselves, because this is not going to be pretty. But you know what actually takes numbers? Counters. And then you can use the counter in the content property. So we can define a temporary counter, reset it to the value that we actually want to display, and then use that counter in the generated content. And that works, right? So even though content only accepts strings, we can convert numbers to strings via counter reset, and that works. Does it actually, though? Does it work? Can you look very closely? Does it really work? I mean, it works here, and it works here, and it works here, and it works here. But does it work here? No, it doesn't. We get 0%. Why did we get 0%? Because there we don't actually have an integer, and counters can only be integers. So actually, we need to correct what I just said. You can convert integers to strings via counter reset. So yeah, that trick only works with integers. Is there anything we could do? Could we convert the number to an integer in CSS? Well, we can have another custom property that we define as an integer. And then we just use the integer data type. We give it some initial value because it's mandatory. And we specify that it inherits. And then we just apply the value of our custom property. We just set that to we just set the integer property to p inside calc. This is important. If we don't use calc, then the browser's internal conversion doesn't kick in. And then use that integer in counter reset, and then use that counter in content. So we can convert a number to an integer by assigning it to a property registered as integer inside calc, and that actually works. And we can even floor and seal. And yes, in the future, we'll have nicer ways to do this. We'll get proper rounding properties. They're actually in the spec. They're just not implemented yet. But right now, there we are. We can't do that yet. In the even further future, we're going to get functions that actually let us convert the text we have into the number we have into text that we can use in content. And that will be awesome. But that is even further in the future. So for now, there we are. Now, the next step, then the last missing part of the puzzle, is the colors. So we want to have this yellow when p is 0, and this turquoise when p is 100, and we want to have the midpoint color when p is 50, and then the in-between colors when p is anywhere in between. So how can we do that? We do that through something used, we do that by mapping the number we have that goes from 0 to 100 to other numbers for the hue and the lightness. So shall we try to do that? And then we use these numbers in an HSL color. So let's try to do that. First, we define our hue, and let's add a comment so that we remember what we've done here. And we use the start value plus the difference between the start and the end value multiplied by the percentage of p. And then we specify a lightness value that also goes from 50% to 40%. This goes the other way. This is reducing as it goes. So we start the first value, 50%, plus the difference between them, multiplied again by the percentage of P. And then we use these two variables in a color. And there we are. We actually got the different colors that we wanted. In fact, if you don't believe me, I can show you it works. Here. I can even go beyond 100%, and it still goes. So this was a special case of what is called linear mapping, where you have a number in one range, and you want to map it to a number in a different range. And there's actually a formula that gets you the calculation you need. But that's kind of complicated to process in a slide, and especially to remember, right? So I built a tool. I built a little app that... bloody hell, I know what's going on here. Let me open this in a new tab. Lovely, the internet fails when, all right, there it is. So you can set your variable name, you can set your range, and like the output range that you want, and it will give you the calculation you need. Oh, there it is, loaded here too now. You can even use this for conditionals. I mean, if you think about it, you have you want to map a range from 0 to 1 into another range. You can see conditionals as a range of 0 to 1, and you just don't care about the intermediate values. But it's the same formula, and you can even define an if-not foo variable and have a much more readable conditional than what we saw with space toggle. In fact, here is what we're going to get in the future, an inline if function. It's going to be super nice. The space toggle version we saw earlier, where the second value was defined through its delta, and then our range mapping conditional, which I would argue is much more readable. I mean, keep in mind, the not glossy variable is only defined once in your style sheet, and then you just use it in every conditional. And another advantage of this approach is that you can do logical operations. It's basically Boolean algebra. Those of you that studied Boolean algebra at school know how these work. So linear mapping allows the same variable to control multiple things, either continuously, as we saw in the color case, or discretely, as we saw in conditionals. And here's another use case. This is actually SVG. This is the SVG, and we can use, we have this CX value that goes from 25 to like 75, which is kind of awkward to remember. So what are we going to do? We're going to use range mapping, so we have a variable that conveniently goes from 0 to 1. And then we can get all the values that from left to right by just changing this from 0 to 1 and anything in between. But what is really nice about this is that, let me try an experiment here. I'm going to write some JavaScript that sets a mouse X and a mouse Y custom property to, you can guess what it will be. The position of the mouse pointer. The position of the mouse pointer as a percentage of the viewport, actually. Let's copy paste it underneath and change that to Y. And there and then inner width to inner height, and there we have it. And now we can go here and set look to that property. And now we went from something that is manual to something that is set based on the mouse position, but we didn't have to change anything in our CX declaration. It's completely abstracted away, like input, where this value comes from, and output, which is where the eyes are looking, is completely decoupled. So I think that is probably one of the most important lessons about range mapping. You can completely decouple input from output. So what is the conclusion here? You might be thinking, well, these are kind of cool tricks, but you know what? I'm going to go back and write CSS the way I always have, because these are hacks. So is this really all a steaming pile of hacks? Yes. But if you think about it, the hacks are in the implementation. The hacks were not in the API. In fact, we used the hacks to get a nicer API. So hacks are not always a bad idea if they're hidden, if they are used to make the API nicer. It's often preferable to trade a higher implementation complexity to gain lower API complexity. You can always change the implementation. It's much harder to change an API. You cannot chase down all the users of your component and tell them to change their code. Overly complex APIs cause a lot more pain than overly complex implementations, just because they have a lot more users. There's a lot more users of an API than developers of an API, and that is true for any API, no matter how popular it is. So, in general, it's a good practice to write components whose CSS properties are independent and each control one conceptual thing. Components that can work with whatever CSS you throw at them. Components whose CSS properties can be modified at any point without breakage. If you need to employ hacks to do these things, so be it. This is not a license to write crappy code. This is about the many cases where you need to make a trade-off between the two. But ultimately, every case is different, and the final decision is yours. Thank you very much.